Hello and welcome back to another Masterminds video. Today we present another episode of Versus, this time on rocket engines. And don't worry, we'll still continue the Versus on rockets. So anyways, into this episode we'll talk about 8 different rocket engines, and we will talk about the thrust, fuel, cost, thrust to weight ratio, and many more. So anyways, make sure to subscribe and watch till the end. So now for the rocket engines that we will be comparing. The first rocket engine is the Merlin engine, then the RS-25, the F1, Raptor, BE-4, RD-180, H1, and the Super Draco rocket engine. Okay, so now onto the specs of these rocket motors. First, with the cost. The Merlin engine cost about 1 million, a little less than 1 million. The RS-25 cost about 40 million, then 15 million, 2 million, and then the BE-4 hasn't been finished yet, so we don't really know. Then the RD-180 cost 9.9 million. Sadly, can't find the cost on the H1 engine, but probably because it's not produced anymore, but so is the F1, so I can't really make an excuse for that. And then SpaceX hasn't released the cost for their Super Draco. So now, onto the next category, we will talk about the fuel sources of these engines. This is a really important category because different fuels burn different amounts with different temperatures and different densities. So anyways, the Merlin engine uses RP1 fuels, or rocket propellant 1. Then the RS-25 uses hydrogen, which is the cleanest burning fuel, so that's good. And it is also the most difficult to contain because it is a gas, which means it's super undense, light. Anyways, then the F1 uses RP1 again. The BE-4 uses liquid methane. Then the RD-180 uses RP1, the H1 also uses RP1, and then the Super Dracos use hypergolic fuels, which are good for standing around, but are super toxic, and when it touches it, it's oxidized or immediately combusts. Then onto the thrust to weight ratio of these engines. The Merlin has a thrust to weight ratio of 182 to 1, 73.1 to 1, 94.1 to 1, 200 to 1. Then the BE-4 is undeveloped and unknown. Then 78.44 to 1, 102.47 to 1. Then the Super Draco is unlisted. Then for the efficiency, the Merlin engine has an ISP of 282 seconds. It's basically measurement of the burn time with a certain amount of fuel for a certain amount of thrust. So anyways, the RS-25 with 366 seconds, 263 seconds, 330 seconds. The BE-4 is unknown again. Then 311 seconds, 255 seconds, and then finally 235 seconds with the Super Draco engines. Then onto the bell pressure. The Merlin engine produces 1,410 psi, or pounds per square inch. The RS-25 has 2,994 psi, 1,015 psi, 4,400 psi. The BE-4 has 1,950 psi, then 3,870 psi, 700 psi, and finally 1,000 psi for the Super Draco engines. Finally, for the companies that design these engines. First, the Merlin engine is designed by SpaceX. The RS-25 was designed and built by Rocketdyne, which is operated by NASA for the Space Shuttle and SLS. The F1 rocket engine is designed and built by Rocketdyne, but is operated by NASA on the Saturn V rocket, which is no longer in use. Then the Raptor engine is being designed and will be built and operated only by SpaceX. The BE-4 is still in design by Blue Origin, and then they will be operated by Blue Origin as well as ULA. The RD-180 was designed and built by the Soviet Union. They are also operated by the Soviet Union as well as ULA. Then the H-1 engine is designed and built by Rocketdyne as well as used by NASA again on the Saturn 1B rocket. Then finally, the Super Dracos were designed and built and are operated by SpaceX. Anyways, thanks for watching. Make sure to share and subscribe for more videos. We make 3 a week. So make sure to subscribe, share, and watch all of those. Bye.